Hello U12s and welcome back to mathematics. In this video we're continuing to look at our continuous probability distributions, and we're continuing to work with the normal distribution. So in the last couple of lessons we worked with calculating the probability of different events happening using a normal distribution, and we used the empirical rule for this. So if we had what we were working with was if you have your mean in the middle and you went one standard deviation below and one standard deviation above, that was 68% of your scores. So that was 68%. And then we continued working down, and if you went 2, that was 95%. And then if you went down 3 standard deviations or above, oh, hang on, this should be a minus, that was 99.7% of your scores. And so here we had that normal distribution that looked like this. And the last lesson we started talking about how you could actually standardize this for no matter what set of scores that you had using z-scores. And so the z-scores was based on a standardized normal distribution where you had a mean of 0 and you had z-scores of -1, -2, -3, 1, 2, and 3. And so those represented just one standard deviation above or below. So -1 was one standard deviation below, +1 was one standard deviation above, and so on. And so this was our normal standard deviation, standardized normal distribution. And so they follow the same rules of these empirical values. And so we were able to calculate a few probabilities using that. Now, what we've looked at so far is when we've got standard deviation scores, which are exact values of 1, 2, and 3. So you have 1 standard deviation away, 2 standard deviations away, or 3 standard deviations away. However, not all scores actually fit into those categories. Let's say you had a score where it was actually like in between, and we had a look at an example where we had a score which was right at, I think it was like 2/3. How can we actually calculate the probabilities of those events happening because they don't fit into these particular empirical rule values? Well, the way that we can do this is by using a table of values, so statistical table actually. So here we can actually get exact probabilities of an event happening based on their z-scores using this table. Now this table looks a bit confusing, but let me just explain to you how we actually can read off scores here. So what this table actually tells you is what is the probability, so this is a probability of your z-score being less than or equal to a value a. So on your standardized normal distribution, what this would look like is if I have a value a at any point, so let's say it's somewhere around here, we have a value a, what we're looking at is we're finding the area under this part here. So the whole area that's to the left of that. So that's what the values on my standardized norm on this statistical table will actually tell me. What is the area of what percentage of scores is less than that particular value? Now the way we do this, if you have a look, it's a table that's made up of a vertical first column and a horizontal first column. And the way that we read these scores are, the first column here are the first digits of my z-score. So this is the first digits of my z-score, so z-score. And then on my top row, so this row over here, so that is your first digits of your z-score, and here, this is your second decimal place of your z-score. So for example, let's say we had a number, let's say we had like a over here looks somewhere around 1.75, let's say 1.75. So what we can do is we can go to the table. Okay, the first digits are 1.7. Oh, hello. Okay, that's not what I wanted. Yep, over here. Ooh, we're back up here. Okay, the first 2 digits is 1.7. So what I'm going to do is I'm going to go into the first column and go to where 1.7 is. So here, 1.7 is over here. And so I'm looking at, let me do this in green. I'll highlight in green so we can see a little bit clearer. Green. Okay, so 1.7 is this row over here. So these are the the percentages for the particular column for 1.7. Then all I need to do is just then look at the last digit. So the last digit is 5. And so all I need to do is just go to 0.05. So here, go along here. 0.05 is over here. Just go down. So what this tells me is that if I have a z-score, probability of a z-score being less than or equal to 1.75, that is equal to 0.9599. So using percentages, that would be 95% or 95.99%. So that's how we can actually use this statistical table to actually help me find the probabilities of events happening given non-exact value z-scores. So here, if we wanted to find like very precise z-scores, for example, so let's say you wanted like 2.88 or something, you can actually use this table to help you find those values. Now, a few things about this table. One, you don't need to memorize any values from this table. So here, note, do not memorize any values from this table. If a question required you to answer using a table, they would give you the table and you just need to read off it. That's all you need to be able to do. The second thing that you need to note is that unless if they don't give you this table, just use the 68, 95, and 99.7 rule to help you actually calculate the probabilities. The other thing is that this table is actually a lot more accurate than that 68, 99, 95, and 99.7. So if they give you a table, use a table instead of your empirical rule, and that's really it. Because there's actually a few scores here. So one standard deviation away. They give you a few more decimal places than your regular 68%. So here, 0.8413. They give you the last two decimal places as well. Similarly, down here at 2 and also at 3, they give you a few more much more exact values than your regular empirical rule. So if they give you a table, use the table here. So, answering questions using this, it's very similar to what we've been working on so far. So what we need to remember is that our normal distribution is symmetrical. So let's say they wanted you to find between two values. So they wanted you to find it between negative 1.75 and 1.75. You just need to remember that it's in, this is symmetrical. You need to remember that on either side, if you want to get rid of half of it, so z-score from 0 onwards is just 50%. And so on. So we're going to be applying some of the skills that we've been looking at so far in this topic. Okay, let's have a look at a few examples. Okay, so I've got actually the table here just to make it easier for us to answer this. So questions requiring statistical tables usually involve standard deviations at non-integer values. So this is the thing I've been saying. So what we notice is that the standard deviation, we find that the standard deviation is it's at a non-integer. It's not at 1, 2, or 3 standard deviations away. It's actually at 1 point whatever. The other thing is that we actually use some sort of calculation to find this out. So we read off the table and then we got to do a little bit of calculating. Okay, so let's have a look at this example. The maximum temperature reached by the water heated in a kettle each time it is used is normally distributed with a mean of 95 degrees Celsius and a standard deviation of 2 Celsius. When the kettle is used, the proportion of times that the maximum temperature reached by the water is greater than 98 degrees Celsius is closest to. Now what we're trying to find here is, if you have a look at the question, we want to find the proportion of times that the maximum temperature reached by the kettle is greater than 98 degrees. So what we want to actually find for this one is we want to find the probability that our random distribution is greater than 98. Now, in order for us to actually use the statistical table, we need to convert this to that standardized normal distribution. So here, 98 is my score. And so I'm going to go, okay, my score is 98. I'm just going to fix up something, sorry. Right, there we go. 98 is my score. I just need my two other values. So here, we've got a mean of 95. U is equal to 95. And my standard deviation is 2. And so we can use that z-score equation that we had look at last lesson. Z is equal to x minus mu over sigma. So the score minus the mean over the standard deviation. We put the values in. So 98 minus 95 over 2. So that's 3 over 2 or 1.5. So what this means is we're trying to find the probability that z is greater than 1.5. It's a bit of a problem though. If you remember, what I said was this table tells you the probability of a z-score being less than a. So here, if on our normal distribution, what I drew was what we're looking for here is if I have a value a, we're finding we find this area here. Unfortunately, I don't want to find that area. Because this time I'm looking at greater than or equal to, I actually want to find this area over here. So what I can do is I need to remember that the whole area under my normal distribution, that's just equal to 1. And so here, if I want to find this particular answer, this is just the same as 1 minus P of Z is less than or equal to 1.5. So we just need to remember that the whole normal distribution has an the area under that curve is 1 because all probabilities add up to 1. And so here, we actually change it, change our equation a little bit so that it matches up there. Okay, cool. So now that I've done that, I can go to my standard deviation. I can go to my table and I can start to find where 1.5 is. Now 1.5, let me have a look at the first 2 digits. 1.5 is all the way over, and it keeps moving. I do not like this. 1.5 is all the way over here. 1.5 is here, and so I'm looking at this row for to find this value. Okay, what's the second digit? Well, if it's just 1.5, that just means that the second digit is just 1.50. And so here, my second digit is just going to be 0. And so I just read down, and that tells me that I have a value of 0.9332. So here, this is the probability of 1 minus 0.9332. I can check that in my calculator. When it loads, 1 minus 0.9332, and we get 0.0668. So here, what we have is that we get answer B. So for this one, we actually needed to do a few things. Firstly, it was a probability of a value being greater than. That's what the question told me. And so here, that was we had to first convert that normal distribution into a standardized normal distribution. So we want to find what z-score it corresponds to. So that just corresponds to 1.5 standard deviations away. But because it's greater than, and our table here only finds it for less than, we actually need to convert that again. And so here, the way that we did that was we remembered that the whole area under my normal distribution is equal to 1. And so if I want to find the other part, I just subtract it from 1. Okay, cool. So that's this first example here. Let's have a look over the page. Example 2019. So here, the concerts at the Mathsland Concert Hall begins L minutes after the scheduled starting time. So like any regular event, you start a little bit late. L is a random variable that is normally distributed with a mean of 10 minutes and standard deviation of 4 minutes. So here I'm just going to highlight that information. I've got a mean of 10 minutes, so mu is equal to 10, and I've got a standard deviation of 4, so sigma is equal to 4. Okay. Let's have a look at this question. First part, what proportions of concerts begin before the scheduled starting time? So before the scheduled starting time. Now, let's just think about this for a second. If something happens before the scheduled starting time, what is its score? Well, in this case, that means that your L minutes is, if L minutes is how many minutes you're starting after the starting time, we want to find the probability that L is less than 0, because if you're starting before the starting time, that just means you're starting before starting time 0. So here, for this first part A, I want to find the probability that our random variable L is less than or equal to 0. Great. Now what we need to do is we need to convert that into our z-score, to a z-score, so we can actually use our table. Okay, now here if I have 0, that is my score, so x is equal to 0, and we've already identified that our mean is 10, and our standard deviation is 4. So here, when we convert that into our z-score, so z is equal to 0 minus 10 over 4, which is just negative 10 over 4, which is negative 2.5. So here, we're finding a z-score which is less than negative 2.5. Okay, let's have a look at our z-scores. Now, if you have a look here, notice all of these values are actually positive. That's not very good for me. I don't know why it keeps moving. I hate this. Okay, that's not great. How can we actually do something about that? Well, I can't find negative 2.5, but I can find positive 2.5. And the thing that we need to remember is that our standardized normal distribution, or any normal distribution, is symmetrical. So what we know is that if I find 2.5 over here, then over here at negative 2.5, the area under this part is going to be the same as the area under this part. And so what I can do is I can just find the probability of a score being greater than 2.5, z-score of 2.5, and we should be good. And so here, this is just the same as the probability of z being greater than or equal to 2.5. And just like we did in the last example, that's just the same probability that's the same as 1 minus the probability of my z-score being less than 2.5. Now the reason why I want to have, so just a reminder, the reason why I want to have it in this form less than is because my table only works for less than. It doesn't work for greater than, unfortunately. So here we're going to actually use this fact here. Okay, let's go and have a look at, let's go and find out what this value is. Okay, so 2.5, I'm going to go to my table. First couple of digits is 2.5. So here, it's over here. I'm looking at this row. And the second digit is 0. And so I'm just going to go down here. And so that tells me that's 99.38. So here, that's going to be 1 minus 0.9938. And so I can put that in my calculator. 1 minus 0.9938, which gives me 0.0062. 0.0062. Okay, cool. So here, just like we did before, we had a random variable that had its own mean and standard deviation. What we need to do is we need to convert that to a standardized normal distribution by using that formula that we had a look at last lesson. So x minus mu over sigma, this one here. And so we had it in so we got that in our z-score. Now, because we were dealing with a negative z-score, unfortunately, our table doesn't work for negative values. And so what we need to do was we need to remember that our normal distribution is symmetrical. And so we could actually rewrite this less than negative 2.5 as being greater than 2.5. And those are the exact same thing. And so here I could go, okay, it's greater than 2.5. And just like we did in the last lesson, we had to convert that to a 1 minus the probability of z being less than 2.5, because this table doesn't work for greater than, unfortunately. And then once we did that, we could find the values and then substitute there and put them in our formula there. Okay, let's have a look at the next part. Find the probability that the concert begins more than 15 minutes after the scheduled time. So here, if we want to find the probability that it's more than 15 minutes after the starting scheduled time. So what this would look like is, I'm going to work over here. That is the probability of our starting, our random variable L being greater than or equal to 15. And once again, we need to convert this to a z-score. So here my score is 15, my mean was 10, standard deviation was 4, I believe. Okay. And so here, this is just going to be, I'm going to put this in my formula. So z is equal to x minus mu over sigma, which is just 15 minus 10 over 4, which is 5 over 4, which is 1.25. And what this is looking like, this is a probability of a z-score being greater than or equal to 1.25. Unfortunately, once again, we can't do greater than, and so we need to convert this to being less than something. So here, it's just the same as 1 minus the probability of my z-score being less than or equal to 1.25. And so I'm going to go to my table. So this time I'm going to do this in green. So I want to find where 1.25 is on my table. So here I look for the first two digits, 1.2. So 1.2 is over here. So I'm looking at this row. So I found my row for 1.2. And then now I need to go to find the second digit. So the second decimal place, which is 5. So here I've got 0.05. And so I read off here. And so that just gives me 0.8944. So this value here is going to be 1 minus 0.8944. Chuck that to my calculator. 1 minus 0.8944. And we get 0.1056. Oh, 0.1056. Cool. So there we go. Okay. So that's for the second part here. So this is the probability that a concert starts 15 minutes or more. Okay, starts after 15 minutes. Okay, let's have a look here. If the concert begins more than 15 minutes after the scheduled starting time, the cleaner is given an extra payment of $200. If the concert begins up to 15 minutes after the scheduled starting time, the cleaner is given an extra payment of $100. If the concert begins at or before the starting time, there is no extra payment for the cleaner. Let C be the random variable that represents the extra payment for the cleaner. So here we have to pay the cleaner, and if the concert starts later, that means that they have to get paid a little bit more because they have to wait longer for the concert. That's what we're imagining here. So what we want to do in part CI, using your responses from A and B, complete the following table. So what we have here is if the cleaner gets paid, if the cleaner has to wait for more than 15 minutes, they get paid $200. So that's what we actually found in part B. This is part B, isn't it? In part B, we found the probability that the concert starts 15 minutes after the starting time. So it's 15 minutes late. So here, probability that it starts 15 minutes late is actually 0.1056. So here, what I can do is, if they get $200, that just refers to this box over here. And so here, I need to write this to 3 decimal places. And so I'm just rounding this guy to 3 decimal places, which is just 0. And we're back up here for some reason again. 0.106. Okay, cool. Now in part A, we also found another thing. We found that the probability of it starting at the starting time, on time or earlier. So here, that's just this box over here. And so for that one, we found that it had a probability of 0.0062. We just want this to 3 decimal places, as the question says here, 0.006. Okay, that leaves us with this middle group here of $100. So if it begins before at or before the scheduled starting time, there's no extra payment. So that was this first box. Now this last box here of 100, how do we fill that in? Well, what we know is that all the probabilities can add up to 1. So to find this value here for 100, I just go 1 minus 0.06 minus 0.106. So let me put that in my calculator. 1 minus 0.06 minus 0.106. Okay, so it gives me 0.834. Hang on, did I do something wrong here? I think I put 1 decimal place off. Yep, I'm 1 decimal place off. Whoops, 0, 0. For the first one, it's 0.06. I knew something was off. Okay, cool. This should be 0.006, my bad. This should be 0.888, and there we go. Okay, that's the first part here. Second part, we were going to calculate the expected value of the extra payment for the cleaner. Now, you could do this in multiple ways. You could put this in your calculator like we did with the probability distribution tables and calculate our mean using just your calculator. Or we could just do it like we normally would with a distribution table. So what we would do is for part CII, we just take our expected value is just each of our scores multiplied by the probability. So here I had 0 times 0.06 plus 100 times 0.888 plus 200 times 0.106. And so here, when I put this in my calculator, I get, so let me put this in, there we go, 0 times 0.06 plus 100 times 0.888 plus 200 times 0.106. So that's $110. So this janitor is expected to get $110 extra for the cleaning fees. Okay. Part 3 is to find the standard deviation of C, and so we've done this already with our probability distribution tables. What we can actually do is, this is a standard deviation, so sigma of C. Also, I realize this is for my random variable C, it should be C. We can actually chuck this in the calculator. We can go mode, stat, one variable, and we can just put in our score. So 0, 100, and 200. And we know that the probabilities of them were, what was the first probability? It was 0.006. 0.006. The next one was 0.888. And the last one was 0.106. So we can chuck this in a calculator, and we can go shift 1, 4 for variance, and 3 for standard deviation. And so it's a standard deviation of roughly $32. Okay, so that's how we answer these questions with a statistical table. Let's have a look at one more example. Now this is in the extra questions underneath. Now I'm just going to check which one I wanted to have a look at just quickly. Okay, this one's the longer one. Let's have a look at that one. Okay, where is it? It's this one, isn't it? It's 2018. Yeah, there we go. Okay, this is on page 46, and this is question 10 on those extra questions from the 2018 paper. Okay, so let's have a look at these questions. we're still going to be using our statistical table, which is why I have it over here nice and handy for us. Let's have a look at question 10c. A hole is drilled into each motor. So they had parts A and B, which aren't relevant to this part, but let's just imagine there's some kind of machinery which is drilling holes into a motor. The depth of the hole is normally distributed with a mean of 20 millimeters and a standard deviation of 0.03. So here mu is equal to 20, sigma is equal to 0.3. What is the probability for a randomly selected motor? The depth of the hole is greater than, so depth of the hole is greater than 20.6. Give your answer correct to 4 decimal places. So here, this score is x is equal to 20.6. So what we're trying to find is, first of all, it is the probability that the depth is greater than 20.6. So here, for my random variable, that p is x is greater, the probability of x is greater than or equal to 20.6. Now what we need to do is we need to actually convert that into a z-score once again. So here, my z-score is going to be x minus mu over sigma, so x minus the mean over standard deviation, 20.6 minus 20 over 0.3, which gives me 2. So here, this is the probability of our z-score being greater than or equal to 2. And like we said before, we can't get greater than using our table, so what we can do is we can write this as 1 minus the probability of z being less than 2. And so here, this is actually an exact value, exact value that we had from our empirical rule. But if we actually used our statistical table, we actually get a much more accurate number than that empirical value. So here, because they've given it to us, we're going to use it. If not, we would just assume that when you have a standard deviation of 2 away, we're going to use that 95% rule to help us out here. But let's have a look here. So this is just going to be, my first digit is 2. It's this whole row here, and because we don't have any digits after that, it's just going to be this first value over here. So for this one, we're going to have 1 minus 0.9772. Let's put this in the calculator. 1 minus 0.9772. So that's let me just check that, 0.0228. 0.0228. Okay, first question. There we go. So this one was similar to the other ones that we've been looking at so far. We have to firstly convert our regular normal distribution values to a standardized normal distribution, so finding that z-score, and then we just read off the table for that value. Okay, let's have a look at the next one. The depth of the hole drilled into a motor must be within 0.5 millimeters of the mean. Otherwise, the motor is defective. So let's have a look here. So we need to be within 0.5 millimeters, or else it's defective. What is the probability that the motor is defective correct to 4 decimal places? Now, here it says it has to be within 0.05. So let's just figure out what the allowable range is. So if the mean already was 20, within 0.5 millimeters of it, what values are that? Well, we've got the lower end, where you've got something that is 19.5 millimeters is allowable. But on the upper end, we've also got 20.5, because here, on either end, you can be within this range and you'll be fine. Okay, so here, for this one, what we want to do is we want to find the probability that it is x is greater than 20.5, and the probability that x is less than 19.5. So that's the cases here. So we want to find all of the probabilities where it's smaller than this value, but also all the values where it's greater than this 20.5. Okay, as well. Now, once again, we need to firstly convert these into z-scores. So let's convert that for the 20.5 here. So z for the 20.5, that's just going to be, let me check, 20.5 minus 20 over 0.3. So let's chuck this in the calculator. So 20, let me put this in a fraction. Oh, I'm still in stat mode. 20.5 minus 20 over 0.3. That gives me 1.66667. So that's 1.67. Let's just call it that. And on the other end, we've got this one, because it's equal on either side. I'm going to just realize here, I'll do the calculation anyway, but I think this should be negative 1.675. Okay, 20 minus that over 0.3, which is so 19.5 minus 20 over 0.3, which is just the negative version of that. So that's here. Okay, so we've got these two values here. So this is just the same as the probability of our z-score being greater than 1.67 plus the probability of our z-score being less than negative 1.67. Now there's two issues here. Firstly, we can't have greater than, so we need to convert that into, we need to convert this guy into 1 minus the probability of our z-score being less than or equal to 1.67. Maybe I'll do this underneath, I have a bit more space. So I'll continue this underneath. So here, so this first part, so here the probability of z is greater than 1.67. It's just the same as 1 minus the probability of z-score being less than 1.67, because we can't have the greater than part. Okay, the second thing is then, well, we also have got this part where it's, this guy here is with negative. So we can't actually have a negative value. So we need to take the positive value, and just remember that our normal distribution is symmetrical. So if I have it, we want to find this part here where it's less than 1.67. That's just the same as finding it greater than 1.67. So here, this is actually, this guy is going to be plus probability is greater than 1.67 for the second part here. So for this guy, that's this part here. And as you notice, that's actually just two lots of this 1.6, z is greater than this 1.67. So I'm just going to write here, this is 2 times 1 minus p of z is less than 1.67. So let's actually figure out what this is. So p of z is less than 1.67. I'm going to go to my table, and it's just here. So 1.6 is over here, first 2 digits, and I'm just going to read across in this row. 6, 7, so I'm rounding to the 7. I'm just going to take this value over here. So that's just 95.25. So here this is going to be 2 times of 1 minus 0.9525. And there, let's just chuck in the calculator, 2 lots of 1 minus 0.9525. Oh, yep, that's correct. And we get 0.9095. Let me just check that with my answers I had before. Okay, that's what I get there. Oh, it's 4 decimal places. Yeah, it should be fine. Okay, cool. There we go. Okay, that's how we can find the probability for this one. Now, there's a third part here. I'm going to go through that in our lesson together, and there's a few other questions I want to have a go at. But hopefully that helps explaining in how to actually read off these statistical tables and how that relates to our standardized normal distribution. So that's it for today's lesson. And I'll see you guys in our online lesson tomorrow. But Year 12s, as always, stay safe, stay healthy, stay wonderful, and I'll see you guys online then. Bye.